Welcome to How to Securely Validate Claude Responses in Python. Today, we're going to learn how to implement robust guardrails and output validation, ensuring safe and reliable AI interactions. Let's dive in and enhance your Python skills for better AI implementations.
In today's fast-paced tech world, the use of AI, like Claude, is growing exponentially. But what happens when these AI systems produce incorrect or even harmful outputs? That's where output validation comes in. Validation ensures that the responses generated by AI systems are safe, accurate, and reliable. In this video, we'll explore how Python can serve as a powerful tool to implement these validations, focusing on Claude's AI. By the end of this session, you'll understand the crucial role validation plays in AI implementations and how to protect your applications effectively.
Before we delve into coding, let's understand why output validation is so crucial. When AI systems like Claude are left unchecked, they can produce responses that are not just incorrect, but potentially harmful. Imagine an AI used in healthcare providing erroneous medical advice, or a finance AI suggesting flawed investment strategies. These are not just hypothetical scenarios, such AI failures have occurred. By implementing robust validation systems, we can mitigate these risks significantly. Validation acts as a gatekeeper, ensuring that only safe and accurate outputs are delivered. This not only protects users but also enhances the reliability and trustworthiness of AI applications. Now that we've established the importance of validation, let's set up Python for our AI validation tasks. First, ensure you have Python installed on your system. You can download it from python.org. Next, we'll need some essential packages: numpy for numerical operations, pandas for data manipulation, and regex for pattern matching. You can install these using pip. Setting up a virtual environment is also recommended to manage dependencies efficiently. If you're new to Python, don't worry. This setup is straightforward and forms the foundation for implementing our validation scripts. With Python ready, we're all set to write some code. With our Python environment ready, let's dive into implementing our first guardrails. Guardrails are essentially rules or checks that validate the output from Claude's AI. Start with basic if-else statements to check the output against expected patterns or values. For example, if Claude is providing numerical data, ensure it falls within a realistic range. Similarly, for text outputs, verify that they don't contain inappropriate language or misinformation. These initial guardrails act as a first line of defense, catching obvious errors and ensuring the AI's output is safe for users. Simple yet effective, these checks are crucial in building a reliable AI system. Regular expressions, or regex, are powerful tools for text validation, allowing for complex pattern matching. In the context of AI validation, regex can be used to ensure text outputs from Claude conform to specific formats or exclude certain patterns. For instance, if Claude generates a response with user data, regex can confirm that email addresses are correctly formatted or that phone numbers match expected patterns. This level of precision is crucial when dealing with complex data. Unlike basic if-else checks, regex offers flexibility and depth, enabling you to handle a variety of text validation scenarios efficiently.
AI systems often encounter unexpected inputs that can lead to errors or undesirable outputs. To manage these scenarios, exception handling is key. In Python, the try-except block allows you to catch and manage exceptions gracefully. For example, if Claude's AI receives an unexpected data type, the system should handle it without crashing. Implementing try-except blocks ensures that your application can continue running smoothly even when unexpected inputs occur. This robustness is essential for maintaining user trust and ensuring that the AI system is reliable under various conditions.
Testing and debugging are critical steps in developing reliable AI validation functions. Begin by writing unit tests for your validation scripts using Python's unitus module. These tests help verify that each function behaves as expected in various scenarios. When issues arise, debugging tools like PyCharm or VS Code can be invaluable, providing insights into where errors occur. By iteratively testing and refining your validation functions, you ensure that they handle edge cases effectively and perform reliably. This process not only improves the quality of your code but also enhances the overall safety and reliability of your AI application.
Maintaining your validation scripts is an ongoing process. Regular updates are essential to incorporate new validation rules or adapt to changes in AI behavior. Documentation is another critical aspect. Clearly comment on your code to explain validation logic, making it easier for others to understand and modify. Refactoring your code periodically can improve efficiency and readability. As your AI application grows, consider scalability in your validation approach. Finally, Use version control systems like Git to manage changes and collaborate with others. By adhering to these best practices, you ensure that your validation scripts remain effective, efficient, and adaptable. Python offers a rich ecosystem of libraries that can simplify advanced validation tasks. Libraries like Cerberus and Voluptuous provide robust frameworks for data validation, allowing you to define complex rules and constraints with ease. These libraries are particularly useful for handling intricate validation scenarios where manual checks would be cumbersome. By leveraging these tools, you can streamline your validation process, ensuring that your AI's outputs are not only correct but also adhere to predefined standards. This not only boosts efficiency but also reduces the potential for human error in your validation scripts. As we wrap up, remember that validating AI responses is crucial for ensuring safe and reliable implementations. Throughout this video, we've explored how Python can be a powerful ally in building robust validation systems, from basic guardrails to advanced libraries. I encourage you to apply these skills in your projects, enhancing the safety and reliability of your AI applications. If you found this video helpful, please like, share, and comment below. Let us know what topics you want us to cover next. Subscribe for more content on AI and Python. Thank you for watching.